Hello fellow learners, welcome to my YouTube channel. This video is going to be an exciting journey into the world of queues and their implementation. Whether you are a tech enthusiast or just curious about the inner working of systems, you are in for a treat. We will be unraveling the mystery behind queues, a fundamental concept in computer science, and exploring their diverse implementations. But here's the catch. We won't just talk theory. We are going hands on with a menu driven program that showcases all the essential queue operations, making this learning experience interactive and engaging. And that's not all. We are connecting dots by exploring how queues can be implemented in the database of Cars24, a leading vehicle resale company. Ever wondered how they efficiently manage the influx of vehicle information? Yeah, without further ado, let's roll up our sleeves and get ready to understand, implement, and appreciate the power of cues. Welcome to the journey, and let's get started. Our first topic is queue. A queue is a fundamental data structure that follows the first in, first out principle. It represents a linear collection of elements where the addition of new elements and the removal of existing ones occur at opposite ends. FIFO, first in, first out principle. In a queue, the element that is added first is the one that gets removed first. This principle mimics real world scenarios such as waiting in line at grocery store or queuing for tickets. The importance of queues in data structure include orderly processing. Queues adhere to the first in, first out principle, ensuring sequential and organized data processing. Buffering data. Queues act as buffers, smoothing the flow of data between components with different processing rates. The next importance is task scheduling in operating systems. Operating systems employ queues to schedule tasks, executing them based on arrival order. The next important is graph algorithms. Breadth first search. Queues are pivotal in BFS, facilitating the exploration of graph nodes level by level. The next importance is print queue management. Print spooling systems uses queues to process print jobs in order they are received. Data buffering in input-output systems. Queues buffer data in input or output systems, ensuring a steady flow of information. Call center systems. Queues manage incoming calls in call centers, allowing agents to handle calls based on arrival order. Message queues in distributed systems. Queues facilitate sequential communication between components in distributed systems. The next topic is types of queues. It includes linear queue, circular queue, and priority queue. Talking about the linear queue follows a straight line structure where elements are added at the rear end and removed from the front. The straightforward arrangement is common in scenarios where a strict order of processing is required. The next is circular queue. Circular queue address certain limitations of linear queues by connecting the front and rear end, forming a circular structure. This allows for efficient use of space and continual data processing. The last type is priority queue. Priority queues prioritize elements based on their assigned priority levels. Higher priority elements are processed before lower priority ones, making this type of queue suitable for applications where urgency or importance is a factor. The different types of queue operations. The first one is in queue. It adds an element to the rear or end of the queue. This fulfills the purpose of expanding the queue to accommodate new data. The next operation is tqueue. It removes an element from the front or beginning of the queue. It helps to process and remove the oldest data in the queue. The next operation is front. It retrieves the element at the front of the queue without removing it. It fulfills the purpose of inspecting the next element to be processed. The next operation is back. It retrieves the element at the end of the queue without removing it. It fulfills the purpose of examining the latest addition to the queue. Yeah, now let's just take the Python program that contains all these operations, which makes you more clear about the working of these operations. In this Python program, at first we are going to add a class Q to encapsulate the functionality of a basic queue. The first class Q is defined here. In this class, we are going to add so many functions. So the first one we are adding here is double underscore in double underscore. Sorry, I gave better. Now so fn bracket self dot items equals to an empty list. This init method initializes an empty list to store the queue elements. The function we are adding here is the is underscore 20 self return the length of the length of the list that have been made above. Self dot item list equal to 0. This isEmpty method checks if the queue is empty by verifying the length of the item list. So the next function we are adding here is the empty self item into bracket. Here self dot items dot append of item print into item. In this enqueue method, it adds an element to the end of the queue by appending it to the item list. The next function we are adding here is eq bracket self if no self dot is empty. That's whether the list is empty or not. Remove item item which equals self dot items dot for all. So print eq in Python else print is empty if operation is failed. And that's yeah, the dequeue method removes and returns the front element of the queue. It checks if the queue is not empty before attempting to dequeue. The next function we add here is front. Non self dot is underscore empty. Front Front, front, element, the, the items of the was print to sneaky and the front operation is still the next. Uh, if talking about this front method, it retrieves and prints the element at the front of the queue without removing it. It checks if the queue is not empty before attempting to access in the front element. The next function we are adding is display. If not, in cells code is empty and two element, two elements, separate items. Or else when queue is empty, display operation is failed. Operation is failed. This much, yeah, if we, it is better if we change this to a small one, queue is empty. It is just, this is necessary. These all are the functions we are adding in this class queue. For better convenience, we are making this as a menu-driven program. So to make it a menu-driven, we have to call the class queue. Queue is assigned, the queue class is assigned to this queue. But we are making it a loop by using while. While true, then which we should give some headings as it is different. The first option we are given is entity. Yeah, the second one, print, second option. If there are people, third one we give here from the front. The fourth one we display we give the option last we should give an option for the user to exit the program. So the fifth option will give exit. Also we should assign choice so that we can store the option that the user have entered to the choice input. But enter your choice. Yeah, the thing is we are going to compare the choices. The this choice equal to one, choice equal to one, which would assign the value to item. Item is equals to input into the element to include and two in Q. And then we should call the function Q dot in Q function. Okay, we should keep item. And then the next one edit choice equivalent to two, where we will call the function include dot dp and edit choice equivalent to three. We'll call the function include dot front. The next we will give the choice number four equivalent to four. We will call q dot display function. The last but not the least, select choice short equivalent to five, which will give the option to break the loop break. Bring it's sick, it's a it's in loop. Then we should break the if any other than these options. If the user type any other than these options, we should give an alert message that you have to enter an valid option. So in valid choice, this enter a valid option. So these much things we have to mention in our program to work it properly. So yeah, let's just run once. Yeah, the program runs like this. It has clean. Yeah, I am going with the first option now. I should add some more elements to the enqueue method. 45, one, first option, then 56. If we choose the second one, it deletes the first entered number that is 23. So it has been deleted from the list. Then if you go with the third option, it will be the first element sitting in the queue. The first one we have entered is 23, but we have dequeued it, so the first becomes the 34. That's why it is showing the 34. Yeah, if you go with the fourth option to display all the elements in the list, it will show the all elements. Yeah, if we enter some invalid options like age, it will give an invalid choice message and alert the user to enter a valid option. Then at last, the exit option is also working properly. This program makes us it helps us to understand the operations in queue more easily. Yeah. Now let's just check the implement in Fast 24. The challenges faced here are managing the flow of vehicles for resale efficiently, prioritizing vehicle based on urgency or seller criteria, ensuring smooth processing and reducing processing time. The solutions are enqueuing vehicles. Add new vehicles to the queue with appropriate priority. The next one is dequeuing vehicles. Remove vehicles based on priority or FIFO, first in, first out order, using stored procedures or triggers. Processing queued vehicles. Assign vehicles to workers or teams. Trigger workflows for inspections, appraisal, marketing, etc. Update vehicle status in the queue table as steps are completed. It also includes error handling, plan for database issues, invalid data, or unexpected queue behavior. Monitor, track queue performance to identify bottlenecks and optimize processing. Scalability. If you expect high volumes, explore distributed queuing systems for efficient handling. Benefits. Yeah, it comes with a lot of benefits when using queues in these type of databases. Faster turnarounds. Vehicles move through processing steps quicker, leading to quicker sales. Organized workflow. Clear order for processing, avoid confusions, and ensure all vehicles get attention. Prioritization flexibility. Prioritize urgent vehicles or those with specific seller needs. Reduced manual work. Automation minimizes manual queue management, freeing up staff time. There you have it, folks, the ins and outs of queues and their powerful implementations. We have covered the basics, explored various types of queues, and even dived into a hands-on experience with the menu-driven program showcasing real queue operations. We have also understood how queues play a pivotal role in the database of Cars24. Remember, the world of technology is vast and ever evolving, and understanding the fundamental concept of queues opens up plethora of possibilities. So keep coding, keep learning. Until next time, happy coding.